All right, we're talking about 7-3 similar triangles. Okay, so if you know the triangles are similar, if I tell you here are two triangles and they're similar. Yesterday you learned two properties of similar polygons. What are they? So similar polygons, which a triangle is a polygon, have corresponding sides are proportional. Right. Corresponding angles are congruent. Okay? Now, as of yesterday, if you wanted to prove two polygons were similar, you had to prove both of those. That every single pair of corresponding sides was proportional, and every single pair of corresponding angles was congruent. Well, when it's a triangle, just like it was with triangle congruence, when it's a triangle and you're looking for similarity, you don't have to prove all of those things. You don't have to prove that all three pairs of angles are congruent. You don't have to prove that all three sides are proportional. Now, one of those, you know of a shortcut already. If you wanted to know that all three angles of one triangle are congruent to all three angles of another, well, remember we had a theorem a while ago that said if two angles of one triangle are congruent to two angles of another, then the third angles have to be congruent because they have to add up to 180. So if you have two that are the same and two that are the same, whatever makes this one be 180 would also make this one be 180. So even if you did have to prove all three angles, you'd really, in a triangle, you'd only have to prove two because proving two would be enough to prove the third one, okay? And it comes to, they found, and this is a postulate. A postulate means that you can't really prove it, but they found that it's true. And the first one is called, the first postulate we're going to learn, actually the only postulate in this section, is called angle similarity. Okay? The way you can abbreviate it in a proof is angle similarity. Now what that says is if two angles of one triangle are congruent to two angles of another triangle. Now, what was our theorem before? If two angles of one triangle are congruent to two angles of another triangle, what? The third angles are congruent. Well, now we know if that's true, not only are the third angles are congruent, then the triangles are similar. Okay? So they found through investigation that you actually only have to know the angles of two triangles are congruent. And if you know that, then having three congruent angles and three congruent angles of a triangle mean that those triangles are the same shape, and it means that those triangles have proportional sides. So you actually don't have to know anything about the sides to know that. Okay? So let me give you an example of where you would use this, not just in a proof, where you would use it in a problem. Okay? So let's say this. Pretend that's a straight line. All right? And we've got A, B, E, C, D. Okay, so if AB is parallel to CD, AB is 4, CD is 8, ED is x plus 12, and AE is 3x plus 4. The directions say find AE and ED. Okay. Well, if we knew these two triangles were similar, then we could know that the sides were proportional, right? Well, can we prove they're similar? Well, proving they're similar, now, instead of having to prove everything, we only have to prove 2 angles of one triangle are congruent to 2 angles of the other triangle. Well, one I know immediately. Even if these lines weren't parallel, that would be true, right? So we know one angle of this triangle is congruent to one angle of this triangle, all right? But now we've got horizontal lines cut by a transversal, alternate interior angles are congruent. Or you could have said these are alternate interior. Parallel lines cut by that transversal. Okay? You can, but you only need 2. So you're done. Okay? You know the third one is, but you don't even need it. Okay? So now, your similarity statement is important though. So triangle ABE is similar to triangle what? Okay, so A on this triangle corresponds to what on this triangle?
Z.
No.
Oh, D.
D. A is that angle. D is that angle. So A goes with D. B on this triangle is what on the other one? C. It's the angle with nothing on it, so it'd be the angle with nothing on it here. And then E on this triangle is E on that triangle. Now, just because a letter is on both triangles doesn't mean it corresponds to itself, but in this case, it did. Okay? The reason we can do that now is look at the sides we have. We were given AB and CD. Are they corresponding sides? AB and CD, yes. So, AB over CD has to equal AE, which corresponds to DE. Right? AB over CD is AE over DE. So now just plug in what you know. That's 4 over 8 equals 3x plus 4 over x plus 12. Okay? Now before you cross multiply, because this is a proportion, you can actually just simplify that to be 1/2. Now that's actually important if you want to check your answer later. This triangle, this one is 1/2 of that one, right? Because 4 is half of 8. So whatever we get for AE better be 1/2 of what we get for ED. Okay? If we've done it correctly. Now if you cross multiply, you've got 2 times 3x plus 4 equals x plus 12. What's next? 6x plus 8 equals x plus 12. So subtract x, you get 5x plus 8 equals 12. Subtract 8, and you get 5x equals 4. So what is x? 4/5. Okay? So now, to answer the question, they didn't ask what x is. They asked for AE and ED. So AE is 3x plus 4. So that is 3 times 4/5 plus 4, right? Which is 12/5 plus 4. 4 is 20/5. And so that is 32/5, or if you would rather, that's 6 2/5. Or if you'd rather, that's 6.4. Okay? I would accept any of those three answers. Okay? For ED, it is x plus 12, which is 4/5 plus 12, which easy enough is 12 4/5. Okay? Which is, we needed it to be double. Is that double 6 2/5? Yes. If we wrote it as improper, that would be 64/5. Is that double 32/5? Yep. Yes. Or if we wrote it as a decimal, that's 12.8. Is that double 6.4? Yes. So either of those is your answer. Make sense? All right. The next one is a theorem, but typically we prove all the theorems. The proof to this one is really strange, and it's not like any other proof you ever do. So to me, it's a waste of time to really teach you this proof because it's not a logic that you use in any other proofs. Okay, so I'm just going to ask you to trust me today and know that you can prove this if you wanted to. Okay. All right. So what this says is this one is a theorem, and it's called side-side-side similarity. Side-side-side similarity. Lots of squiggles. Okay? And what that means is if the measures of all corresponding sides of two triangles are proportional, then the triangles are similar. So far, we've had two new ways to prove that triangles are similar. What was the first one? Angle, angle. So all you have to do is prove two angles of one triangle congruent to two angles of another. If you do that, then the triangles are similar. Once they're similar, you know all three angles are congruent, all three sides are proportional. The next one says all you have to do is prove that all the sides are proportional. And if all the sides are proportional, you don't have to prove anything about the angles. If all the sides are proportional, then they are similar. But once they're similar, you know all the angles are congruent. Okay? So let me show you a way that would come into play. So I'm going to give you a proof. Give me just a second because I'm going to make it up on the spot. All right, hold on. Take two.
Exactly.
It's really too big. Time, take 3.
Yeah.
Because I have no room to write the proof now. All right. Third one worked. Okay.
That's not a perfect shit. That's what that is.
All right. So I'm going to say this is 6. CD is 4. BC is 6. DE is 4. AC is 9. CD is 6. And I want you to prove that okay. So to save time, I'm just going to write all the givens and just call that given. Okay. But pretend I wrote all those things. All right, so let's write it. So AB is 6, BC is 6, AC is 9, CD is 4, DE is 4, CE is 6. Okay. Well, since this is in the similar triangle section, what do you think you might want to prove about those two triangles? That they're similar, okay? Because then it would give us that. But we have 2 ways to prove they're similar. One is to show that 2 angles are congruent. Do we know any 2 angles of these triangles are congruent? No. There's no vertical angles. There's no corresponding because we don't know anything's parallel. Nothing. Okay, so our only option is side, side, side. So let's see. What does AB over CD equal? Well, that would be 6 over 4, which is 3/2, right? And that is just substitution. Because all we did was, I gave you this. We wanted to find that. We plugged in 6 for AB and 4 for CD, right? And then you could also say simplify too. All right? Likewise, what is BC over DE? Well, it also is 6 over 4, which is 3 over 2. For the same reason. And lastly, what is AC over CE? Well, that is 9 over 6, which is 3 over 2. For the exact same reason. Okay? Look at what we have now. There's somebody with a nasal problem in the hallway. But what else do we have? Wish them all the best. See if I have room to fit this all in the camera. What else do we know now? Well, all 3 are the same. So can we say AB over CD is equal to BC over DE is equal to AC over CE? Yes? Because they're all 3/2. Now you could either say transitive or substitution. Because if that equals that, but that equals that, but that equals that.
Let's try it.
Okay, let's call it transitive. And it's with steps 2, 3, and 4. Okay, well now, if you've shown all 3 pairs of corresponding sides are the same ratio, then you've shown all 3 pairs of sides are proportional. So, according to the theorem we just learned, we can now say triangle ABC is similar to triangle CDE. And the reason is side, side, side similarity. Right? Now, if we know triangles are similar, what do we know? We know all 3 pairs of sides are proportional. Well, great, we already knew that. But we also now know all corresponding angles are congruent. So we can say this angle right here, angle BCA, is congruent to angle DEC. Angle BCA is congruent to angle DEC. Now the reason is corresponding angles of similar triangles are congruent. You could have also just said definition of similar triangles. Because the definition of similar triangles says all sides are proportional, all angles are congruent. Okay, well now look, we have 2 lines cut by a transversal and corresponding angles are congruent. So we've got what we're trying to prove now. We can say BC is parallel to DE. The reason is if corresponding angles are congruent, lines are parallel. Okay, so that's a way that you will use side, side, side similarity.
We got like 2 more.
All right, the next theorem, okay, so if you only know angles, what do you have to know to prove 2 triangles are similar? You only know things about angles. You just have to know 2 angles of one are congruent to 2 angles of other. If you only know things about sides, what do you have to know?
2 sides.
You have to know all 3 pairs of sides are proportional to all 3 other sides. Okay? Yeah, I almost did. Well, what if you know some angles and some sides? Okay? Well, if you know 2 angles, it doesn't matter what you know about sides. Because if you know 2 angles, it's angle, right? But what if you only know 1 angle? Okay? If you know 1 angle, then if you know the sides that make up that angle, the 2 sides that make up that angle, are proportional to the 2 sides that make up the other angle, then the triangles are similar. Okay? And that one is called side angle side similarity. Okay? Somebody close that door, please. It says, if the measures of 2 sides of one triangle are proportional to 2 sides of another triangle, okay, so far, if we knew that, the only way we would know that the triangles were similar is if we knew the other pair of sides were also proportional, right? Because we know 2 sides of one are proportional to 2 sides of the other. So far, the only thing we know is that you have to you have to prove the other sides. But this one says, and the included angles are congruent, then, I don't know why it keeps doing this. It doesn't do it on the computer. It just does it there. Then the triangles are similar.
Gone.
You forgot what?
The screen recording.
Oh. Yeah. Selena's going to get all the crazy things that happened. The nose blowing, the laughing, I don't know what's happening. But, all right. The screen going black, but she can't see it because the screen on the computer is not going black. But, yeah. Hey, Selena. Hope you're feeling better. All right. So the next one. Let's look at this example in the book. It's example 2. It says, see if I can draw this in less than 3 tries. Got it first time. All right. So we got A, B, C, D, E, F, G. Okay, so we are told that FG is congruent to EG, that BE is 15, that CF is 20, that AE is 9, and that DF is 12. It says determine which, if any, triangles are similar. Okay? So let's just go through. Well, so what are our ways? We've got angle-angle similarity. We've got side-side-side similarity. And we've got side-angle-side similarity. Now, why is there no angle-side-angle?
Because if you have 2 angles, you don't need.
Yeah, 2 angles, you don't need to know anything about sides. Okay? So that's why it's a little different than congruent triangles. Because remember, congruent triangles, angle, angle, angle didn't work. But for similar triangles, it does. Side, side, side works, side, angle, works. Angle, side, angle, there's no reason because you know 2 angles. Okay? Angle, angle, side, there's no reason because you know 2 angles. Okay? So, all right, so first, FG is congruent to EG. Does that tell us anything else? This triangle is isosceles, which means what? Anything else? These 2 angles are congruent. So that helps us. We're probably not going to use side, side, side now. Okay? Because we know an angle. All right, now, they're talking about BE. So to me, that means they're probably referencing this triangle, right? So I'm going to draw those 2 triangles not overlapping. Okay? This one is ABE, and this one is DCF. Okay? Now we know from this drawing that this angle is congruent to that one. So do y'all see what I did? I just took these 2 triangles and pulled them apart. Okay? So now I could mark BE. It's hard to mark what BE is here, right? So BE is 15. CF is 20. AE is 9. And DF is 12. Okay? Well, this looks like a prime candidate for side angle side. Because look, we know an angle and both sides around it. We know an angle and both sides around it. So, What do you think 9 would correspond to? 20 or 12? 12. They're both multiples of 3. So that. And 15 would correspond to 20 because they're both multiples of 5, most likely. So let's see. What is AE over FD? Well, that would be 9 over 12, which is 3/4. Then so this corresponds to that with a ratio of 3/4. So let's see, what is BE over CF? That is 15 over 20, which is also 3/4. So this corresponds to that with a ratio of 3/4. So do we have side angle side? Yes. We have two sides of one triangle in the same proportion to two sides of another, and the included angle is congruent. So we can say triangle AEB is similar to, now the order we say it is important. A on this triangle is what on this triangle? D. Because A is beside the one squiggle, but has nothing marked on it. That would be D. Okay. E on this triangle is what on this one? F. It's the one angle we know is congruent, and it's the included angle. The included angle over here. And then B on this triangle is C on this one. That's your answer. Okay, now there are other orders you could have, if you'd written the first one in different order, you'd have to write the second one in different order. But, okay? All right, one last example. Now, once it's not absolutely freezing outside, we're going to go do this one day, okay? And this is something you can really do, okay? It says, to estimate the height of a tree, a Girl Scout sights the top of a tree in a mirror that is 34.5 meters from the tree. So here's what's going on. Girl Scout is standing right here, okay? There's a big tree over here. Okay? She puts a mirror on the floor. Ground, I guess, not floor, but she can look in that mirror and see the top of the tree. Okay? Now, this is something you'll learn in physics, but mirrors are known for whatever angle light goes into a mirror, it comes out at the exact same angle. So because this is a mirror, we know that this angle is congruent to that angle. Okay? So now they told us the mirror is 34.5 meters away from the bottom of the tree. Okay? The Girl Scout is 0.75 meters away from the mirror. She measured the distance from her eyes to the ground. We're going to do this. And it was 1.75 meters. How tall is the tree? Okay? So I'm going to call this A, B, C, D, E. Selena, this is page 356 in your book, if you're watching. Okay? All right. So, now let's draw it without all the messy drawings. We got 1.7. Everything's in meters, so I'm going to leave it off. 0.75 meters, 34.5 meters, and x. Okay. Do we know these two triangles are congruent? Well, we're not going to use side, side, side. I mean, not congruent, similar, sorry. We've got angle, angle similarity. We've got side, side, side similarity. And we've got side, angle, side similarity. Which one do I know we're not going to use? Why? Because we know an angle, right? Okay. Well, think about it, though. Well, if we were going to use side, angle, side, what would we need to know? Well, we could find the ratio of these two sides, right? But we would need to know the ratio of these two, because it has to be the sides that make the angle. It wouldn't be these two sides. We would need to know that these two sides were proportional, and we have no idea what those distances are, right? So we can't use side, side, side. So we have to use angle, angle. It's the only thing left. Okay? Well, we've got one angle. Can we prove this angle is congruent to that angle? How? What? You can't. Sorry. Okay. Can we prove this one is congruent to this one? Yes. Because both the girl and the tree stand up straight. So that's a right angle, and that's a right angle. Okay? So, by angle-angle similarity, we can say triangle ABC is similar to triangle EDC. So, we now know, since they're similar, all sides are proportional. So the two sides we know that BC corresponds to DC, the same way that AB corresponds to ED. Now the reason I chose those sides is because two of them we knew, and the other one was the pair that has what we wanted to know. Okay? I do not know what is going on with the projector. Okay. All right, so BC is 0.75 over DC is 34.5 equals AB is 1.75 over ED is X. If you cross multiply there, you get 0.75X equals 60.375. Then how do we figure out what X is? Divide both sides by 0.75, and you get 80.5 meters tall. That is a tall tree. It's like 240 feet. Okay? Yeah, it's like a 24-story building. Okay? Tall tree. Does that make sense, though? All right. The last thing in this section is kind of common sense, but let's talk about it. It says similarity. Now, this is of triangles. Is reflexive, symmetric, and transitive. Okay? Okay, well, let's talk about it. Did I assign you 35? No, I didn't. So we're going to kind of prove them right now, but we're going to do informal proofs. Reflexive means what? What's the reflexive property of equality? Something is equal to itself. What's the symmetric property of congruence? Something's congruent to itself. So what do you think the symmetric property of similarity of triangles is? A triangle is similar to itself. So is that true? Is triangle ABC similar to triangle ABC? Well, let's think about it. So well, it's really easy because all you got to do is prove that two angles of this triangle are congruent to two angles of that one. Well, angle A is congruent to angle A by the reflexive property of congruence. Angle B is congruent to angle B. So, you got it. By angle-angle similarity, a triangle is congruent to itself. Now you could have done any of them. You could do side-side-side similarity, because what is the ratio of AB to AB? 1. So AB over AB is 1. What's the ratio of BC over BC? 1. AC over AC? 1. So all three sides are in the same proportion, so by side-side-side similarity. Okay, so you could have done either way. All right, symmetric says if triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. Okay, well, this one's easy too. If these two triangles are similar, what do we know? All their sides are proportional, all their angles are congruent. So the angles are if you can do angles, always do angles, because you only got to prove two of them and you're done. Okay, so what do we know about the angles of these two triangles? We know that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F, correct? Well, by the symmetric property of congruence, if A is congruent to D, then D is congruent to A. If B is congruent to E, then E is congruent to B, and you're done. You don't even need the third one. If these two are congruent and these are congruent, by angle-angle similarity, these two triangles are similar. Okay? And then transitive. Transitive says if triangle ABC, the second one was symmetric. Reflexive is to itself. Symmetric is you can flip it, which is backwards to me. I think reflexive should be you flipping it. But anyway, if ABC is similar to triangle DEF and triangle DEF is similar to triangle GHI, then triangle ABC is similar to triangle GHI. Well, what do we know if this is true? We know that angle A is congruent to angle D, and angle B is congruent to angle C, right? And we know C is congruent to F, but I only want to know two of them, so I'm stopping there. Well, if this is true, we know that angle D is congruent to angle G, and angle angle E, this is supposed to be an E. I'm like, why is this not working? Congruent to angle H. Sorry. A is congruent to D, B is congruent to E. Sorry, that's supposed to be an E. Okay, here, D is congruent to G and E is congruent to H, because all angles of similar triangles are congruent, right? Well then, what do these two together mean? If A is congruent to D, but D is congruent to G, you can say that A is congruent to G. And that's the transitive property of congruence. Well, if B is congruent to E and E is congruent to H, you can say B is congruent to H. Okay? Well, if two angles of this triangle are congruent to two angles of the other triangle, by angle-angle similarity, those are similar. Okay? So similarity is reflexive, something similar, a triangle similar to itself. It's symmetric, If one triangle is congruent to the second one, then this, or I keep saying congruent. One triangle is similar to the second one is similar to the first one. And then transitive. If one triangle is similar to a second, and that second one is similar to a third, then the first is similar to the third. Okay? All right. I'm going to give you all the rest of the time today to work on 7.3, but also ask any questions you have about 7.2. But the 7.3 homework is page 358 to 359, 13 through 33 odd, quiz on 7.1 and 7.2 Friday.
So you said we're not taking quizzes in 7.3, right?
Correct, because on Friday you're studying for Midchapter test, which will be Monday, on 7.1, 7.2, and 7.3.
Interesting.
You sure can.